Hello guys, this is CodeNCode, and in this lecture, this is segment tree series, and in this lecture we are going to solve the first practice problem, that is RMQSQ, taken from SPOJ. If you look at the problem says you have to find the minimum in a given range. So you are given a list of n integers and you are given q queries. In each query you are given two indices I and j, and you have to find the minimum integer in that range. The indices are 0 based. So n, that is the number of elements, can be as large as 10 to the power 5, while there will be only 10 to the power 4 queries. So input is n, that is n integers, and then we would read the n integers, and then number of queries, and then each time L and R, or basically I and j. So it says 1 1, and since we are working with 0 base in index system, so 1 1 is this element, minimum of this is only 4, and 1 2 means minimum of these two, minimum of these two is 1, so we are printing 1. So we are supposed to output the queries in either square root of n time or log n time. So we are going to use segment tree to solve this problem. If you haven't seen the lecture, let me just delete all of this. If you haven't seen previous 2 or 3 lectures of this series where I have explained everything about building and querying segment tree, then go check out that, because we are going to start coding. So first let me make it bigger. Now we will take an array, integer array, to store all the numbers, and then we are taking integer array for segment tree. So segment tree takes 4n space, so I am taking an array of 4n size. Since n is 10 to the power 5, I have taken 4 into 10 to the power 5 array. And now we have 4 variables n, q, l, and r, and the number of we have read n, that is number of nodes or number of elements in the array. Then we are running a loop from 1 to n, and if you see, we are using one base index system. That is not a problem. All we have to do is take L and R, and then instead of querying for L and R, we would be querying for L plus 1, R plus 1. That is not a problem. So we are reading integers using one base index system. That is not a problem. We are reading we are saving in array 1 to n. After that, we are building the segment tree. Now the build function takes 3 parameters. First is index of the node in the segment tree, that is segment index. This is segment start and segment end. I have explained all of these in previous video lectures of this series, so I am not going to explain what is SN, SS, and what is SE. This basically tells you at this index the segment tree node contains answer for this range. SS and SE suppose are 1 4, so this index saves result of array from 1 to 4. So if segment start is equals to segment end, that is we are at leave node, and then what we will do, segment let me just, yes, now if we are at the leaf node, then at the segment index, this is the segment index, at this index we are going to save that element, because when SS is equals to SE, so you are you are at 0.44, that is what is the solution of range 4 to 4. 4 to 4 is a single element, and that single element is this. So solution minimum of single element would be that element itself. That is why at the index, at current index, we are saving that element itself. I have explained already, but again I don't know why I explain. And then we would calculate mid, because now we have to build, now we are not on the leaf tree, no, we are not on the leaf node. So what we would do, we would build the left subtree. Left subtree would be build left would be 2 times si, the index of left node would be 2 times si, and then it would be from si to mid. We have built the left subtree. Now we would build the right subtree, 2 into si plus 1. The right subtree has index of 2 times I plus 1, and it would be from mid plus 1 to segment end. After we have built the left and the right subtree, now we can build the current node or current subtree. So solution of current would be minimum of left, that is segment tree of 2 times si, and right, which would be segment tree of 2 times si plus 1. So since we have built the left and the right subtrees, I am taking the minimum of left and then right, and then whatever is the minimum of that would be result of current segment tree node. So already explained this one in the previous lecture. So this is how you code. Now for the query, what we are doing after building the segment tree, we are reading Q, that is Q queries, and in each query we are given L and R. So we are printing minimum of range L plus 1 R plus 1 because the input is in 0 base in index system, so we would be printing from L plus 1 R plus 1. Now the query function takes 5 parameters. Si again is segment index, the index of node where in the segment tree it is stored. So segment index, this is segment start and segment end, this is query start and query end, basically L and R. Now there is this condition: if segment start, if the current segment starts after the query index has already ended, that is we have to answer for QS to QE, that is the query segment ends at QE. If the segment start already is, if segment start is ahead of query end, if segment start is ahead of query end, that means we are out of bound and this segment doesn't contain the answer of this query. Or if segment already ended before the query even starts, so segment end is below query starts. If that is the case, then this segment doesn't contain anything, that is there is no what we say interval, these two intervals do not intersect with each other, they are completely disjoint. If that is the case, then we would return something like infinity, because we are finding minimum, and since this segment doesn't contain anything of this segment, then we should return something from here that would be ignored completely. So if you return infinity, that would be ignored completely while calculating minimum. So since infinity is not defined, so returning tens power 9 would do the trick, or you can write in tens power 9, or in C++ you can return int max. Int max is defined, this is the maximum limit of an integer, so it is something like infinity, you can treat it as infinity. Now since there is no intersection at all, so this segment doesn't contain anything of answer, so we would return something that would not contribute into the solution since you are calculating minimum. So if you return infinity, then this would be of course thrown away, or otherwise this segment lies completely inside the query segment. So how we can check that? If segment start is greater than equals to query start and segment ends is less than equals to query end, so what it tells you is that this segment is completely inside this segment. If that's the case, we would return the answer saved at the segment tree, this segment index, that is we would return the solution of this node completely. That is why we return segment tree of SI of segment tree. Otherwise we would calculate minimum is equals to segment start plus segment end divided by 2. We would return what? Minimum of left subtree, that is QUER 2 times SI. To go left, segment start would be same and would be mid, because now we are breaking it from mid, so start to mid, and query start would be same and query end would be same because the range is not changing. And this is from left subtree, and this one would be from right subtree. Segment start would be mid plus 1 because this takes care of start to mid. Now this would take care from mid plus 1 to segment end, and then again query start would be same and query end would be same. This is how we calculate or we perform the query operation. After that everything is set, so let's run it. mid, there's a problem with it. Min cannot be used as a function. Query, okay, why? Query would return integer and this one would return integer. Oh, mid was not declared in this section. Yes, this time we don't get any error. Problem, the test case is there are 3 numbers, 1 4 and 1, 2 queries, 1 1 answer is 4, 1 2 answer is 1. So let's submit this and see. Submit and see. Change the language, submit language to C++, GCC 14. I hope we don't get any error. Whew. So we have submitted it. It's running on test case 1. Running on test case 5. Accepted. So this was range minimum query. And if you haven't seen the previous lecture, of course go see that, because that is how you would understand this code, because I've explained everything in previous 2 or 3 lectures, I guess. So this was the first practice problem in it, and then in the next lecture we would study about point update, and after that we would take a problem of point update, 2 or 3 problems from point update. Then we will move on for range, that is lazy propagation. So thank you guys for watching. This was all for this lecture. See you next time. Till then, keep coding. Thank you.